Hello, everybody. This time I don't have to do a demo, thank God. So all is well in the world, at least from my perspective. So we have a panel of people here. The title of this panel is Challenges and Tips for Developing Applications in the Cloud. So we actually want to try to use this session as a session where we can get technical questions out there that are going to challenge you as PHP developers in the cloud. And this session is going to work really good if you guys contribute questions. So everybody who thinks they're really smart, raise their hand. Okay, only one person raised their hand in the whole audience. Then we're really going to get in trouble when the question part comes up. But all the dumb people that have questions, you can go to the microphone on either aisle and ask your question. This session is being streamed live, so your voice will go out over the internet and you'll be famous. Unfortunately, your face won't go with it, so you'll only be so famous, but that's at least the best we can do at this point. So these are the members of our panel. They come from, obviously, some pretty broad backgrounds here. We've got Amazon, IBM, Red Hat, OpenShift, and Rackspace on the stage. I'm going to just ask everybody to introduce themselves briefly, give you their name, a little bit of background around them so you can understand, where they're coming from and give yourself a little bit of foundation for that. So, Tobias.
All right. Hello, everybody. Does this work?
Oh, yeah. It's working now.
So my name is Tobias Kunze, Toby, more commonly here. Started as a software developer, like most everybody here. Then ran portal operations and development for Lycos in Europe for a number of years. Out of that, co-founded a startup that was a platform as a service, and was actually the CDO there. So I'm not technically the CDO for Red Hat OpenShift, but that Red Hat OpenShift is now that product. So I'm a cloud platform architect there. And yeah, so I've been in the platform space for probably 4 or 5 years now, and it's definitely changing.
Hi, I'm Adrian, Otto from Rackspace. So both entrepreneurs, I think. Tobias with Makara. I founded Phonality, which is a Los Angeles-based startup, and my first job out of college was also a startup, an internet service provider. I've been with Rackspace for 4 years. I work in their strategy group focused on platform. So I have a background that's esteemed in mostly engineering, a little bit of software development, and I do code PHP.
All right, I'm Jeff Barr, Senior Web Services Evangelist for Amazon Web Services. You heard more than enough about my background this morning, so I won't repeat that. Amazon employee for 9 years.
And I'm Mac Devine. I'm an IBM Distinguished Engineer. I'm the Director and CTO for our cloud portfolio and our SO business inside of Global Technology Services. And I originally came from the WebSphere Java world, but don't hold that against me.
All right, thank you. So we're going to go ahead and jump into some questions we have here. We have some pre-canned questions, but obviously the better questions are the ones that you guys want answered. So once we get rolling here, please, if anybody has a question, step up to the microphone. Be glad to take it. In fact, if you want to be before the pre-canned questions, try to say that 3 times fast. Jump to the microphone right now. Too late. So, guys, one of the things that's interesting, I think, as people develop software for the cloud is that some stuff needs to be done differently. If you could think of 1 or 2 things that you think are the key things that they need to consider as they build an application for the cloud, what would that be? And since Adrian has the mic, we'll let him start first.
I'm going to say more than 2 things, I think.
Uh-oh.
So I'd say, how many of you run your servers in clusters today? Okay, so all of you who are used to running your servers in clusters, keep doing the same things, because all that stuff applies in the cloud. For those of you that are going from single server environments to clusters for the first time, I would advise that you stay away from things like piling lots of data into PHP sessions. I would try to keep your applications as stateless as possible. Try to keep your sessions very light. Don't write to the database excessively. from your clustered application. I mean, the same sort of things that apply in a clustered environment apply in the cloud. But most importantly, there's a difference between running your application in a controlled environment, running your application in a public cloud. The public clouds have lots of resources, particularly if you're in an environment that's elastic, where you're automatically scaling your app. You can get into big trouble when you make code releases if you're not properly profiling your application before and after you're releasing it into the wild. So I'd be very careful as every time you do a code release into the cloud that you do a full profiling of your application so that you don't get surprised after you've run your application not knowing that it's taking up hundreds of servers worth of capacity and your bill is stacking up to 4 and 5 digits worth of dollars per month to host. So
Max, you got the mic. You want to comment, or Tobias, somebody?
Yeah, so one of the things that people often forget is that many times on-prem you had kind of a dedicated environment. And so being able to kind of transition from a dedicated environment to a shared environment that you got to make sure that you've built in the proper security into your applications. You can't depend on the fact that, okay, nobody can get behind my firewall and the IT department's handle my security. If you're going to start developing apps on a public cloud, you can't just assume that public cloud provider is going to properly secure every single thing that needs to be done about that app. You need to be able to take ownership for yourself to do that piece as well. So it's not to say that you can't rely on some of the services that the cloud provider provides, but you need to be thinking differently. It's a shared environment. It's an accessible environment. It's all about having the ability to collaborate more quickly and easily. And with that collaboration and that flexibility, there comes more risk that you as a developer need to start taking more responsibility over.
Tobias?
All right, perfect room for me to jump in. So I do agree that you need to worry about security, but you also have to realize that you do get effectively infrastructure that has a lot of security focus already built into it. And so you need to worry about application level security, but the infrastructure is generally going to be taken care of for you by the infrastructure provider. So as far as like the things to think about differently, I like to think about you shouldn't get too attached to individual resources. You shouldn't think of individual server instances as particularly precious or noteworthy. You need to think of them as essentially transient and replaceable, and that same advice actually lets you handle scalability, fault tolerance, and high availability as you think about bringing more instances into play and shutting them down as you no longer need them. You don't get attached to any particular instance, and you don't think of it in any special way. You build your systems in such a way that you can add new instances as needed, that you can load balance across them, and when you don't need them, you kill them with effectively no regrets.
Sure.
Alrighty, yeah, I wanted to step back like maybe 1 or 2 steps. How many people do you know about platform as a service versus like infrastructure as a service? Quick show of hands. I see 5, 4, 10. Well, not a lot. So I think as you move your application workload to the cloud, first, clearly, congratulations. That's definitely, the way of the future. The other thing is look at what kind of cloud, the right abstraction, how do you match your application to the cloud offering? That's extremely crucial, right? If you have a very simple application, do you really have to go all the way down and, be a sysadmin? If you have a complex transactional application, is scaling the right thing for you? These kind of things matter. Does your application write files? Do you need to open sockets? These kind of things, right? Cloud offerings are extremely different in that regard. So even if you think, oh, it's just a virtual server or whatever, right? There are huge differences. The other thing is, look at it from the coordinate system between like customizability and ease of use. This is one axis. How much do you get offered versus how much do you want to and have to do yourself? And the other thing would be how open or closed is it really, right? I'm not necessarily talking about vendor lock-in, but really Is it something that I can bring my existing application to, or is it something where I can use my existing programming models to the offering, or is it an entirely new offering for greenfield applications, right? So I think matching application to the cloud is really, really, really important. A little bit more, and I'm done in a second. A little bit, a little bit more abstract, maybe is think about why you're doing that. Think about how your processes change, right? And we may get into this later, but you are creating environments for your application, and that creating these environments becomes very cheap, as opposed to telling your IT, hey, can I get 3 more servers or so, and then half a year later you get them. It's in a matter of minutes, right? So, and that fundamentally changes everything about how you develop, how you QA, how you stage, and so forth.
So actually, several of you mentioned something that I think is actually pretty interesting for the PHP people. So, if you're talking about physical servers, the file system is there, and you tend to rely on it pretty heavily. Even in virtual instances, when you shut down a virtual instance, it tends to retain its file system unless you revert it to a previous snapshot. Might be interesting to talk about sort of the ephemeral nature of local storage, because I think if you depend on local storage for your application, that I think is a huge issue. So, I don't know if it's worth elaborating on ways that you want to design your application to avoid that kind of technology. I'll start with Tobias this time.
Yeah, in our experience, because we just happen to focus on applications that, everybody writes, right? And everybody writes some code that maybe you shouldn't write in certain situations, but that's just the way it is. So we just happen to provide a shared file system in our platform, but if you don't run on an environment where you have this, this luxury as your cluster expands and shrinks, that somebody manages a distributed file system, then yeah, don't write to the file system, right? If it's a photo upload application, store it, somewhere else. Store it in a, where you keep state in a database if need be, right?
Right. I think some of the other vendors have ways of dealing with this problem that are a little different as well. So, and I know, Jeff, if you want to talk about how people would deal with this in Amazon, and then we'll give other people a shot at this as well.
Sure. So if you store local to the instance, then that instance has local disk storage, and at the point when you shut it down, then that local disk storage is also going to go away. So a couple different ways that people architect for storage that has a lifetime independent of the instance. We have something called elastic block storage, where you can create virtual disk volumes, and you can attach those to different instances over time. Or you can use a cloud-native storage system, like our Amazon S3, for example, lets you store objects in the cloud, and you can store literally as many objects as you want and get to them at high speed. So you'd want to basically think of starting to move from, let me move my old app unchanged and simply put it on effectively servers hosted in the cloud, to start looking at the cloud and saying, what are the unique features that the cloud brings to me, and how can I actually build my application such that I can start to take advantage of those unique features of the cloud.
Adrian?
So this is an area where the Rackspace products and the Amazon products differ. The ephemeral storage concept is kind of central to the way that the AWS system works. The Rackspace cloud uses a different concept for storage. Every node has persistent storage rather than ephemeral storage. And we don't have the EBS, we only have the local storage. So if you put something on the local node, you can expect that it will remain there. If there's a crash, after crash recovery, the data will still be present. But I would say anybody running in a platform paradigm should try not to rely on any kind of local storage. They should try to put their stuff into key value stores, stored in services like S3 and Cloud Files. Try to put it in NoSQL systems, and if you can't avoid it, put it in your SQL database.
Mac, any comments?
Yeah, so a couple of the guys here kind of hit on it. One of the things that's unique when you're doing cloud-based development is that you have more options. And so making sure that you understand what the cloud provider at the infrastructure layer or the platform layer provides you so that you can take advantage of it so that you're just not trapped into, okay, I'm doing it this way because I've always done it this way because I've been bound by a physical server in a physical environment, all right? And so looking at it, say, okay, let's step back and when I'm designing my application, okay, what are my options? What's going to make the most sense for this particular workload? Maybe it is primarily local storage because maybe it's a transient application and you want to do things very quickly. Maybe you want to have that kind of robustness in terms of recovering that data if you have some kind of outage, or maybe you need to have that data so that it can be shared with others in more of a collaborative fashion. The key point being is that you've got to take a step back and say, okay, what are my options? And consider all your options, consider what the requirements are for your particular workload, and then pick the one that makes the most sense for you.
Right. I think there's a good point there in that, we sort of take certain things for granted when we're talking about on-premise kinds of things. If you say, well, Linux is sort of like Linux, and yes, the distros are a little different, but some things like the way the file system works, you can pretty much assume is the same, and even to a great extent between Windows and Linux. But as you go forward, you've got to look at the options that the different cloud providers are providing you, and they have their various pros and cons. So for different applications, different providers might make sense. One of the other areas I think, guys, that people are exploring is the aspect of database access. So we have, people typically have used SQL databases. You're seeing an expansion of NoSQL databases. I wonder if you guys can comment a little bit on the connectivity to databases and where you see that going as far as SQL first, and then we'll probably circle back around and talk about NoSQL databases in the cloud in a few seconds. So when we start with Adrian, he's got the mic again.
All right, so when you're talking about platform as a service, database is essential. You've got to have a relational database present because most applications that are designed today expect to use them. So any platform as a service offering worth its salt is going to have a SQL feature in it. Our platform services at Rackspace come with these database services. But that said, SQL as a design pattern for storage is not ideal for cloud applications. You really would rather not have a central data storage design if you could avoid it. If you were designing a cloud application from the ground up, you would try to have a more distributed data model rather than a central data design. Many applications lend themselves very well to having just a very small amount of data in the very middle of the application. But the ones that require the cloud in order to run, that are very, very large, you really want to try to decentralize that data model, get it into a different kind of a storage paradigm where you're not depending on a central point for all your data.
Go ahead, Matt.
Yeah, so that's a good point. I mean, if you're taking an existing app and you want to basically cloud enable it, your choices are probably somewhat dictated by the behavior of the existing app. If you're going to write something from scratch in the cloud, again, just like I said before, you step back and you say, what are my options? What are going to be my best design points? What are my best architectural points that I could utilize? And so I think that's when you really start making your decisions about what you use. It's based off of those kinds of requirements, whether you have existing requirements that you need to be able to leverage and extend, or whether it's more of a greenfield opportunity and you want to take full advantage of the elasticity of the cloud.
Tobias?
So to me, something that's really implicit in the promise, if you will, of the cloud is the fact that you have the opportunity to think really, really big. And you can think of building an app, and you can think of what if it suddenly scales up and I have tens of millions of users in a very, very short amount of time. And when you have that opportunity to do that, you need to really think architecturally and think, where are the bottlenecks going to appear and where are the limits? And if you start thinking about relational models, you can get an awful lot done with those, but you have to start thinking, well, what happens when I go beyond the scale of a single server or the capacity of a single disk drive or the number of requests per second I can deal with that I can extract from a single server, and how much time do I have to invest in profiling, tuning, and re-optimizing and re-indexing my database? And so part of the thought process, I think, has to be about, now that I have this opportunity to build something and I have the access to all these resources to let me potentially scale to what I think of as world scale, do you want to let that database be the constraining factor that maybe when you're on that really steep part of the exponential curve, where do you want to be focusing your resources? Do you want to be focusing on building a really awesome app, or do you want to be just buried in server logs and tuning and profiling and so forth? So that to me is also kind of a little bit more abstract way of looking at, do you still want to go relational when you move to the cloud?
Yeah, I think that's a very important point. So one key characteristic, I think, in the cloud, and actually at any level, is the availability of stuff. Right at home, you have to build this yourself. You have to see, where's the web page, the wiki, how do you download the software? If you actually want to change, from a MySQL or whatever you're using. In the cloud, that's fundamentally always there. So think about on Amazon, for instance, not just for example, right? There's RDS. There's a relational data store. There's like simple databases. There are a lot of vendors offering Mongo, for instance, just to name a few. As you move up to the platform level, that gets even simpler because everything essentially turns into a checkbox, right? You have the whole open source ecosystem at your fingertips. And what that enables you to is to choose to change your architecture. For instance, a lot of us have used, for instance, Memcache as a cache front end to expensive queries, right? And a very common pattern. And not necessarily the best one, because now I pepper my code with if-then-else stuff, right? It's like just as bad as like C with if-defs. Maybe I don't even need it. I could just maybe try Mongo in a in-memory sharded version, or try something like Couch or Redis. Redis is also, it suits a lot of applications. So stuff is just really there in the cloud, fundamentally, and that is really a game changer.
Yeah, so I mean, in a way, guys, and let me see if I can summarize this. You're sort of talking about a problem that I would categorize as historically people had DB administrators who would set up databases and they would scale them to sort of maximum capacity, and then you could maybe add web servers, remove web servers fairly quickly, but you didn't really think about the flexing and scaling of the database servers. People tended to sort of go vertical with the database servers. And what you all seem to be saying is that as you proceed into this cloud environment, we need to look at database technologies that are more elastic, just like the web server technologies would be. And you're sort of all, in a way, sort of leaning towards the idea of either a database service provided by the cloud vendor as part of their offering, or as leaning towards sort of NoSQL databases that tend to have this sort of elastic nature built into their very core. Is that a pretty accurate summary, just in general?
Yeah, I think, if I can take the mic for a moment, I think if you can just show your hand, who knows what third normal form is in SQL? Well, maybe, 10%, 15%? If you don't need necessarily SQL, right? You're probably going to do something wrong, like coding a for loop over a table or whatever, right? So it comes down, you give up some generality if you go to no SQL, what's called no SQL. But in exchange, you get more scalability and less points of failure.
Less things to worry about.
It's just the more modern way of coding stuff. Your data needs probably don't always need SQL.
Mac, you look like you have something you want to say down there.
No, so the key point that we're all trying to say is that you're not bound by the rules and regulations that you weren't once bound by. And so don't get trapped into thinking, okay, I'm going to do things just like I did before, I'm just going to do it in a different place. Because that different place is completely different. There's different parameters, different services, and so the biggest mistake people make is, oh, cloud's nothing but a hosted version of what I'm doing on-prem. And that's anything but the truth. You have so much more possibilities by taking advantage of the services that are provided by the cloud infrastructure or the platform provider that you've chosen. Not taking advantage of that, at least not taking advantage of them because you haven't looked at them. Maybe you look at them and says, no, I can do this better myself. That's fine. That's your choice. But you at least need to make sure that you at least inspected the landscape and understand, wow, I have a whole list of possibilities that I was not able to do before because of the restrictions that were placed on me by either my company, the capital expense, the operational expense, whatever those constraints were. Those things are significantly lowered now with the cloud. And that's one of the reasons why you see it taking off.
Sort of, unless you have something strong to say, I'm going to relate that to something that I think is sort of a related topic, and you're talking about rethinking things. I'm just going to ask people in the audience, how many people have actually a real staging environment that really is a copy of their production environment, like a real copy? Notice that not everybody's hand is up, okay? This is actually, by the way, one of the biggest pain in Zend's backside, because people don't set up staging environments. They push things live. They don't really test them that well, and then they yell at us because we broke something in their application with a software update. And we try not to do that, but sometimes things change, and people don't really do that. I think the cloud actually also changes the way people do things operationally. There's not the same sort of level of barrier of entry to set up a full staging environment. To clone an existing implementation is relatively simple. Can you guys talk about a couple of things that you think that really changes operationally that people need to think about as well? Because I think we're moving to more developer operations than big ops, IT ops. And
so, do you want to start? Okay, yeah, absolutely. This is like, cloud has many sides, but this is another fundamental side that, standing up environments is so cheap. It fundamentally, I try to say this, initially, fundamentally changes a lot of processes that you're used to. Just as an example, like we at now Red Hat, right? We used to run regression tests over the weekend, right? Actually, a lot of tests, complicated software. So we changed this completely, being a cloud company, to, every time somebody commits something, we kind of wait a minute or two, whether there's a second commit, and then we spin up 100 machines, as it happens on Amazon. And a couple minutes later, all the results are there, right? Or customer demos, continuous integration. Everything happens, really just like that. There's no provisioning that we have to do. Everything is scripted, automatic. And once you get used to that, there's no going back. Right?
Jeff?
So somebody at Amazon did some calculation, and they discovered that we actually do a software release somewhere around every 7 seconds, averaged out over the course of a year. And you have to get to the point in your development where releasing and deploying are just very, very routine. They're not like hold your breath and be ready to panic if something goes wrong. You have to get that to the point where you're super, super comfortable just rolling out new things all the time, rolling them out. Maybe you put things behind a load balancer, and you maybe you put them in like 10% of the code on the new server, or run 10% of the traffic on the new server. Watch it for a little bit, watch the logs, make sure there's no surprises, and then launch the new instances, and then server by server, retire the old ones, and then put new ones into practice. You don't need to own twice as many servers for a very brief interval that might be a couple minutes or a couple hours at worst. You're going to have more servers running than you need, but it's not going to cost you a whole lot of money. It's going to give you a very clean, very comfortable, very flexible release process. And as you start to think about releasing more often, you start to think more about scripting and automation, and so you take away that worry and that human variability out of the release process as well. It just becomes something that's so routine that you don't have this, when you start to be worried about releases, you then say, well, let's hold off on a little bit. We'll just wait till we're a little bit more confident. We've got a little bit more things to release. The less frequently you do the releases, the more nervous you're going to be about them. So the cloud gives you this ability to be, you can practice to releasing enough that you can become very, very confident in your ability to do so.
Yeah, so those are really good points, because I think a lot of times, the buzz around agile development, all right, when you don't have something like a cloud that provides your infrastructure and some of the operational services, it's kind of hard to be agile, right? You can't truly be agile on-prem. There's still certain boundaries that are there. So being able to have the ability to bring things up, test them out, validate, go back, that cycle, that life cycle of agility is really important, and the cloud gives you a lot of flexibility to do that. So I think getting the hardest thing about cloud is changing human behavior. Right? We've all kind of been programmed to do things a certain way for a certain period of time, and you want to You want to change, kind of gene therapy. You want to change your DNA, so you start thinking of things in the context of, okay, I've got all these potentials that I could do with the cloud, and I need to factor them into how I do my development and be able to be as agile as possible by taking advantage of the elasticity and some of the other factors that the cloud brings. So that gene therapy, I call it, you need to start indoctrinating yourself so your DNA changes, so you don't just do things just because I've done it this way all along, therefore I'm going to continue to do it. That's the worst thing you can do.
So I think about this question much more tactically. I think about it as like, I have this cloud, this programmable infrastructure, this platform as a service. What can I do with it that I couldn't do before? And it's the fact that you can create a model that describes your application's entire environment. You can set up dev, promote it to staging, and finally promote it to production. And the actual environment that you tested and you validated with your regression and all of your testing discipline is what actually ends up in production. And then what used to be production gets killed off, and you start all over again next time it's time to go through a release cycle. I think it's extremely powerful, and I think that makes things much more efficient than it ever was.
Yeah, that's actually a really good point. Guys, I assume you must have questions. Please, if you have questions, step to the mic. If you're at the mic, I'll stop with canned questions. We'll move on. I can't imagine no one has any questions. I mean, I realize they're explaining stuff with incredible brilliance, but, oh, look, a question. See? If you embarrass people, it'll eventually come up.
Oh, it takes a whole lot more than that to embarrass me. I'm a speaker.
You want us to try?
Go for it.
Okay.
No, I guess my question is directed at the panel as a whole. How do you perform business analytics, business intelligence queries out of your NoSQL storage solutions? Okay, the blank looks was not what I was expecting, guys.
That's a very good question. The answer is it depends on how big that data is and what we're analyzing. So if we're trying to answer a question about like what's our sales volume for a particular kind of service that we're offering, we would put that into a business intelligence software through an ETL process and query it just like you would in your own enterprise. But if what we're trying to do is analyze operational data, like what's going on with all of the aspects of our network, what's going on with all of the email that's coming in and out of our hosted email service, we may have hundreds of terabytes worth of data to crunch through, and in that case we use job systems like Hadoop. We put Quartz on top of that. We run MapReduce analytics against the data, and that's how we get our answers.
So we see that MapReduce style programming is one of those like fundamental things that they should teach in elementary school to get folks understanding that programming model, and it shouldn't be thought of as an advanced model. Just this idea that you can divide things up into multiple phases, and that you can do mapping across an arbitrary large array of processors, and you can then reduce and you can boil down results that quickly. That's not just for like the leading edge. We see that business analytics is something that every company should at some point have the ability to do, and it's not going to become optional at some point. Business is very competitive, and when your competition starts to say, well, we can chew through all of our multiple, tens of gigabytes of log files every day, we can run through those in a couple of minutes with a MapReduce model, and we can figure out what's going on in our customer base. If they do that and you don't, then they're going to win and you're not going to win. So we do see that programming model is fundamentally important.
I would agree with that, but I guess my question becomes, you can't ingest data into Hadoop fast enough with any degree of certainty that the data has actually been committed to disk. So you have a durability question there. Same with Memcache, same with Redis. So I don't see how your data solution for the cloud solves the durability issue that the SQL side produces. I mean, what I've heard you say is that we really need to look to the NoSQL solutions, and I certainly do believe that they have a place, but I've got 1,100 webheads and 600 MySQL servers. How am I going to fit that into your cloud?
Well, I think it's an important question. I don't think that it's necessarily a cloud question. In the end, BI, I don't see a lot of BI packages in the field, by the way, in the segment that we're talking about. So a lot of people do Hadoop-oriented stuff, MapReduce operations and these things, but the solution that I see seems to be slow replication, for instance, out of Mongo, right? And then run offline processing on it. So that's...
Right, but a lot of these people here are PHP developers who are deploying their website to the cloud to run, I don't know, an online record store, whatever it is. That's or registration from the sign-ups for speaking engagements, ZendCon. I don't see how the NoSQL solutions are still going to provide the data reporting. I mean, everything that you've said works well from an operational standpoint, where loss of data is permitted.
These kind of questions you get, sorry if I'm sticking with Mongo, but it's with a simple DB find, you can just get this within the same web request. It's not really BI. I wouldn't call this BI. It doesn't generate the amount of data that you need to then look from a completely different angle in order to answer your BI questions.
Well, what's up with the fact that the common BI tools, be it Business Logics, JasperSoft, Pentahow, don't speak to any of those back ends. So the commonly available tools don't fit your solution set.
So I think you might have read too much into some of the earlier statements in terms of, when we talked about SQL and no SQL, we said, it depends on the workload, it depends on the characteristics of the existing apps. It also depends on whether, I'm taking an existing app and I'm making it available in the cloud versus kind of a greenfield kind of opportunity where I have a massive scale and there's data spread out, where I have lots of volume, lots of variety of data. So I think, one of the things that I know that we're doing on the IBM Smart Cloud is we have a smart analytics pilot that we're going on right now with our large enterprise customers. Many of them have traditional applications, are using traditional BI tooling on-prem, making that available as a service. But we also, at the same time, have our big data platform with our big insights and doing things like Watson, where it was based off the Hadoop model. So we're trying to basically have kind of a two-pronged kind of BI analytics strategy, if you will, because we really don't believe that there's a one-size-fits-all kinds of solution. And our job as cloud provider is to give you the most toys possible. I like to say, the cloud with the most toys wins, because invariably that's what's going to happen. When you have most flexibility in terms of things that you could potentially use to solve your particular business problem, the better off you're going to be. Trying to have a one-size-fits-all, I think is asking for trouble, just like, keeping yourself kind of bottled up into kind of a physical view of the world or even a virtual image view of the world gets you into trouble. I think it gets you into trouble, too, if you say, I'm just going to always pick, no SQL, or I'm going to always pick SQL. It really depends on what the requirements are and the characteristics of that application.
I think there's an interesting, thing in what you said, which is some of these common tools today don't support NoSQL databases, but technology advances, and I think at some point they're going to have to start looking at how do they harvest data out of these databases, because there's nothing to stop you from taking an application that uses a SQL-oriented database, and I don't think anybody here was saying don't do something with a SQL-oriented database. What they were saying is that these other technologies have the ability for the database to grow and expand much like the rest of the system would grow and expand, and that's a little bit harder to do with a SQL-oriented database. It's not impossible. I mean, it can be done, clearly, but I think it's a challenge that ultimately the market is going to evolve and products are going to evolve. I mean, think about things that work in the cloud today that didn't work in the cloud before. I mean, they're going to change, and they're going to, I think some of this technology is racing to catch up with other technology all the time. I don't know if anybody else wants to comment.
So So I guess I want to follow up on your question and make sure I understand it completely. Are you concerned about SQL versus NoSQL? Or are you concerned about how you get the analytics out in real time versus batched? Or what's at the essence of it?
The real-time batch, I hadn't even brought Hadoop into the conversation. When you were mentioning engineering analytics, that makes sense.
Right.
No, I guess the statement that I was really trying to drive home was certainly the NoSQL solutions have a place, and I don't know any shop today that is doing medium to large scale work that doesn't have some NoSQL solutions, just as they have some SQL solutions in place.
That's
Many
right.
of them have large SQL infrastructures.
Right, we have both.
But to scale SQL and scale non-SQL takes the same amount of engineering work. Different in nature, but one does not scale any better or worse. They just have different sets of complexity. And from the conversation that was presented, I was left with the impression that, well, just throw NoSQL at it and you can scale indefinitely. And that really doesn't work.
Yeah, I think one of the things you were bringing up earlier is durability. There are time windows when you're using a storage system that's designed to be very performant and very distributed. MongoDB, I think, is a good example of this one, where there is a period of time at which you are committing data that's not yet on disk. And if you lose the node during that time window, you will get data loss. And the reason why we make these trade-offs is because we need to have very highly performant systems, and we don't want them to cost us millions and millions of dollars. So if I were to take a traditional SQL solution, say I want to commit every row of data, how much is that solution going to cost me? I'd go to Oracle and ask the question. I'd go to Teradata and ask the question. I'd ask the question to very many vendors, and the answer is going to come back, it's going to cost a lot of money to solve that problem at the scale you're at. And so that's why we turn to alternatives that have different durability characteristics. And Hadoop is widely used in the very largest web installations, right? Yahoo is using it, Google is using it, Rackspace is using it. We're all case studies in the Hadoop book. And the reason why we are using that is because we have analytics needs and problems that otherwise would be totally cost prohibitive to do in a more traditional model.
Let me interject something in here too. I think this is exactly, in a way, an interesting kind of conversation that we intended to get in this panel, because what's interesting about this conversation is we're talking about pitfalls and things that you can do differently. And what's really interesting here is just even the concept of absolute consistency is very similar to a concept that used to exist in clusters called coherent caches. And people talk about, oh, I need my cache to be completely coherent and exactly the same on all the servers at all the time. And the reality is that's an incredibly hard situation to create. And at the end of the day, you're almost better off thinking, well, maybe my cache isn't going to be coherent and consistent across my entire cluster. Maybe it's going to have eventual consistency. And when you start talking about web-based applications where people are staring at a browser screen for 10 minutes, we run into this every day. I want to buy something on the store. It said there was one left. I've been staring at the screen for 5 minutes. I finally picked buy, and in the meantime, Tobias bought the really cool thing that I wanted, and you go, God damn it. You've got to deal with those things. And I think what the guys were talking about is when we talk about design changes people need to make, we need to think about the potential value that you might get if you can build for something which is eventually consistent, and sharded across somewhere and will eventually all sync up. And that's not going to fit every application.
Right. So when I order a book from Amazon, I may eventually get it. My order may eventually be written to disk, and it may eventually be fulfilled. So the book may eventually show up at my door.
Well, eventually consistent isn't typically in units that large. Typically, like with our database products, like there's one, our SimpleDB, for example, eventual consistency is usually like single-digit milliseconds, in worst case, tens or hundreds, and kind of extreme cases, 99th percentile kinds of things. So eventual consistency just simply means that when you have any distributed system, that you have a synchronization phase. That it can actually, right? there can be a time when some reads immediately following some writes do not actually return what was just written because it hasn't actually propagated out to all of the storage nodes just yet. That's the eventual consistency we're
Right,
talking
because it doesn't fit everything, and I'm going to use my moderator's privilege to kind of declare a little bit of a rat hole here. And I'm glad to have you guys continue the debate afterwards, but I don't want to monopolize the whole conversation on one topic. There got to be other people who have questions here. Hopefully not the same question. On the other hand, if that's the question we want to talk about for the rest of the time, I'm sure people will be glad to talk about it. Yeah, go ahead.
One of the problems that we've had adopting cloud technologies is inconsistent I/O performance, and it seems like it's the kind of physical characteristics of the disk making them seek to run all these different applications at the same time kind of inherently limits what you can do with I/O on the cloud servers. And I'm wondering if any of you have offerings coming out that will address that problem in some way. I know that specifically elastic block storage seems to have performance issues, or at least a lot of people perceive performance issues with it when it comes to I/O bandwidth.
Let's see, I'm certainly not going to announce anything new from the stage. We're always trying to make everything better. How about that? And we're certainly aware that customers keep pushing the edges of what it is that we can do. And the cool thing, I think, one of the cool things about the cloud is the fact that it's not like when you build shrink-wrap software and you ship it off to your customers, you really don't know how it's being put to use, and you can't see operationally how well things are doing behind the scenes. You might be able to ship instrumented copies of some of your code to a few of your customers, and with any luck, you get some of the data back. When you're actually running an online service, you get to watch all the meters and gauges and dials behind the scenes, and you get to see how well are these things performing in real customer situations, and you get to take a long-term view of these, and you can say, okay, we observe this now, and let's actually see if there's ways we can get those numbers from where they are to a point where we're going to make customers happier at a later time. Again, I can't go into detail, but that's something that we do all the time in all of our services, where we're looking behind the scenes, and we have this concentrated, aggregated view of all of the low-level performance metrics of the services, and we're always putting out something new that's going to make it somewhat better. So generally with these kinds of systems, you won't see quantum improvements in them. You will see that if you were to benchmark them at kind of snapshot intervals, you'll see that they seem to get better all the time, is the kind of goal that we have for them. And also as an engineering discipline, it's far better to roll out make a big change in a series of small steps than to have you generally won't see like a version 1.0, 2.0, 3.0 of a web service. You will see that it has gradually attained more features over time and better performance and so forth. So I don't think I actually answered your question, but we are indeed aware that our customers are pushing these services really, really to their limits. And when we do see those limits being pushed up against, we say, is there something more we can do to keep customers happy or make them even happier?
Tobias, go ahead.
Yeah, I think I just want to there's raw I/O performance, and yes, you can do man versus machine and get the best out of it. And but one thing often in the cloud, turns out to be totally different afterwards. Once you look at it, step back. And what I want to say is fundamentally what not scales is architecture, right? If you really go after I/O performance, there's always going to be a wall that you're going to hit, right? And so if you think scalability matters, performance matters there, I think you always have to have a backup solution as well. So maybe it's an in-memory database, or maybe, that leads to other problems, no question, right? I'm just pointing out. So at some point, once you transgress the single machine border, you can switch on the different architecture. And cloud makes this really easy, right? It's very cheap, so the cost equation changes dramatically. And that's what it would focus on. As you move to the cloud, don't bring your existing paradigms, some of them yes, but don't bring them all. Look at how you could work around it, because it's really flexibility is what cloud excels at.
So Mac, can we comment? Or
Can I ask a follow-up to your question, which is what system are you running that is experiencing the variable I/O that you are concerned about?
Right now, most of our systems are actually on Rackspace Cloud, and it is generally query performance from relational databases tends to be highly variable.
Okay, we may have something that you will like soon. I don't know what I'm allowed to say, in this kind of an environment, but there are storage technologies that solve this problem that we are developing on right now.
So are you saying that there will be SSDs in cloud servers soon?
He's not saying anything.
I wouldn't say that. I wouldn't say that.
Nobody heard anything. It didn't exist. It doesn't happen. Would you like me to bail you out on that a little bit further?
I'm just saying there's storage technology that does solve the variability problem, particularly for the SQL application that we are working on now.
Cool. One of the things that I was talking with a customer about, and it was something that we discovered when we ported Zend Server to the cloud. So Zend Server had a number of mechanisms that did certain things that actually utilized the file system for caching. And we actually rewrote that when we moved to the cloud to actually be something where we put it into memory and then we release the thread back to do its thing. And asynchronously, the memory cache backs to the file store. And those are the kind of design changes you need to think about in the cloud. In the case of SQL, where you're going through a SQL service and you're sort of relying on the back end to take care of that. But that's essentially what happens when you move an application to the cloud. So we moved to essentially a memory cache with a backing store because you couldn't necessarily have predictable performance writing to EBS, or you couldn't necessarily have predictable performance. And those are the kind of design changes I think we've been talking about, things where you say, well, I used to rely on the Linux file system being super fast, and it is, except if you're going to store it into EBS, or I'm not picking on EBS in particular, you're going to store it into EBS or something that's ultimately not on that server and over a wire that a number of people are sharing. You have to sort of program for those things and some design changes that you need to consider in your application. Go ahead over here.
Yeah. One of the common things I've seen with people doing planning on the cloud is, the major thing everyone wants to talk about is performance. But the one thing I hear, below in the back rooms, if you will, is security. And you guys brought it up here in the sense that the other coders are saying, well, what you do is, your data that's very sensitive, that you keep on the private server, but on the cloud you keep the public data. And Jeff, you had mentioned something about, well, we have our own security. Can you give us some idea of something? I mean, because otherwise I'm assuming if I have mine on the cloud and he has if he's on the same server, on the same cloud server as me, and he can access my database and access my data, that's a concern. That's obviously I want to know.
Well, let's see. I have an entire PowerPoint we could go through if you'd like. So security and availability are probably the top two things that we always focus on. Without those two, I don't think we actually have a legitimate cloud business. So we have put a lot of investment into security. We have gone through a number of different certifications. We've got SAS 70, ISO 27001, PCI DSS. We have customers building HIPAA applications on the cloud. We publish a ton of details in some security and compliance white papers. We have a chief information security officer. We're happy to let you talk to him if you have particular questions. And what our customers find, this question comes up all the time, and it's not a new question. We have put a lot of work into making sure we have the certifications, the right answers to the tough questions. And as people start to dig in, generally they find something kind of interesting. They find that a large-scale cloud provider, we can make investments in security that are either more expensive or longer term than most people are willing to make on behalf of their individual organizations. And so it's not cheap to go through SAS 70 audits, for example. And if you have a moderate-sized data center, if your data center is simply a closet in the back of your building, you just simply are not going to be able to go through and do that. Whereas a lot of the large-scale things that we need to do for security, the cost is ultimately not that dependent on our own scale. So we can make that investment once. It can be a large cost, but it's not really proportional in any sense to the size of the operation. And so we're willing to put that investment in time and in actual cost to do that. We're happy to discuss many, many details of the way we do security. I'm happy to talk to you offline if you'd like as well.
Yeah, I think the other thing that's important to understand is you have really two layers of security typically. Typically, your cloud infrastructure provider will provide a wide variety of security, like Jeff talked about, with regulatory compliance certifications, just operational security. But also, what you'll see from all of the cloud providers is that giving you security services that you yourself as the developer can utilize and bake in and protect your own system. So we call that a kind of client control cloud type service. So in other words, if you have a particular set of security that you want to bake into your offering, you have the ability to do that. It hooks into our services, but it also you have the ability to do that yourself. So as an example, if you want to encrypt your virtual image when you spin it up, and you're the only, so because you don't really trust that we're going to keep the isolation, if for some weird reason somebody were to access it, they wouldn't be able to get to any of the data. So there's those kinds of things where you have actually, in many cases, more security in the cloud than you actually do on-prem. A lot of times, you think you have a lot of security on-prem, and some of it is the fact that you think you have a lot of security on-prem.
Yeah, I'm sure Sony thought they had a lot of security too, but needless to say, that hasn't worked out quite as well for them. But I think what we're getting at here is, and sometimes things get misinterpreted. We talked about security being an important consideration, and I think they're just a matter of going through and taking advantage of what's there in the cloud providers in a lot of cases. And in other cases, you have to consider, like you said, regulatory concerns of do I have to keep certain confidential data somewhere where I can put my fingers on it because a government regulator is going to say, show me the database server that has that data on it. And you have to go like this. And they don't know what it means when you say, well, it's out there somewhere.
And actually, as a developer, if you're utilizing the services that are available from the cloud provider, it allows you, the developer, to focus on the application level security, not the infrastructure security, the things around that. So it actually gives you the opportunity to do a better job building your application because you don't have all these auxiliary things to worry about because they've been taken care of by a trusted cloud provider.
Adrian?
Yeah, so part of the issue is that we're all scared. We're frightened. We're terrified inside that something might go wrong with our security. And by default, we fall back on, well, let's just do it the way that we always did, right? Let's put up the walls around it and let's do it in-house is the fallback solution. This is what the regulatory guys want you to do. They want you to run it internally. So Rackspace's answer to that is great. We have OpenStack. OpenStack is a private cloud. It's compatible with our cloud. If you must run your things internally because you don't trust or because you're regulated in such a way that you can't use a public cloud or you don't want to, you can still use cloud technology, not with all the benefits of a public cloud, but with most of the benefits. You still get programmable infrastructure. You still get greater levels of efficiency, but you can run your own cloud.
And I think that's you're seeing a lot of that. People are talking about hybrid clouds and hybrids between public cloud and private fixed infrastructure, and also public clouds combined with private clouds. And I don't know if we want to quickly wrap up on that because we're winding down on time, and I'm sure everybody would like to comment on that one a little bit. So thanks for the question. It was a good one.
One more thing that I just wanted to point out is security is a huge field, and as Jeff points out, and Mac and Adrian here, there's on many, many, many levels. One huge level, it's not PCI or it's not necessarily certified, but it's human error. And cloud or platform fundamentally does away with a lot of human error because all these environments tend to be standardized, right? So once you do something on one application install environment, the same thing is going to happen on the other one. So you only do things once, or a platform takes care of distributing changes, for instance. If you need to tweak something on your application, it's going to be automatically always synced across your servers, right? So those are like passive, think of it as like passive security. So it's not all just insecure in the cloud. And of course, you want to be as variable in your architecture as possible. Maybe talk back to your data center, keep the most important data there if need be. But I think this is going to be solved over time.
Okay. Anything else, guys, or should we wrap up? Okay, I want to thank everybody. Hopefully you found this useful. If you didn't, fill out the feedback cards on the forms, and we'll know what to do different next year. But I want to thank everybody and thank the panelists as well. Thank you very much.